So here's the setup. We have a struct, some thing. Importantly, this does not derive, it doesn't implement clone or copy or anything like that. So, we can't be copying things around willy-nilly. And we have this function that we want to call that takes a slice. Okay, so it takes this reference here to an array of things. And then here in our function that we're writing, we have a reference to a thing, but we don't actually have the thing. And we want to call this library or wherever it's coming from, this function takes slice. We want to call this function and pass in arg somehow, right? However, of course, this doesn't compile because, well, I mean, if we look at this error message, it says expected a reference to a slice, right? But it found just a plain old reference to the thing. And if we try and put this argument inside of an array like this, it still doesn't compile because now this is a reference to an array of references. We can see here it's still saying an expected thing and we found a reference to a thing. So how can we do this? Well, this is an instance where the standard library is going to come to save the day. We have this function here, std array from ref, this guy right here. We just pass in our arg and it works perfectly. We see what the return type here, the return type here of this function is a reference to an array of length 1. And actually, if we look at the definition of this function, we see it's using a little bit of unsafe code here to convert the pointer, this reference to just a thing, to a reference to a list of length 1. And as it happens, those are basically the same thing. It's just kind of a type semantics thing going on here, but you can easily convert between these two pointers because they're effectively the same thing.